MS Ramaya University of Applied Sciences.
Hello students, let us discuss the experiment on study of function generator IC and audio power amplifier. The aim of the experiment is to design, construct and test the performance of a function generator using IC 8038. To design, construct and test the performance of an audio power amplifier using IC LM386. The IC 8038 waveform generator is a monolithic integrated circuit capable of producing high accuracy sine, square, triangular, sawtooth and pulse waveforms with a minimum number of external components. The basic principle of IC 8038. The operation of IC 8038 is based on charging and discharging of a grounded capacitor C, whose charging and discharging rates are controlled by programmable current generators IA and IB. When switch is at position A, the capacitor charges at a rate determined by current source IA. The pin configuration for audio power amplifier is as shown in the figure for the circuit connection. The audio amplifier provides both voltage and current gain for signals from the detector stage so that a loudspeaker may be driven. The design equations and design parameters are shown here for both signal generator and audio power amplifier. The figure shows the circuit diagram of function generator and the output waveform. The output of the function generator is a square wave, sine wave and triangular wave. The output will be taken at 3 different pins as shown in the circuit diagram. The figure shows the circuit for audio power amplification and output of the amplifier. At the input using signal generator 1 mV and 1 kHz frequency is fed to the circuit. It's a low frequency input. At the output, the signal will be amplified. Audio speaker also can be used for finding the amplification of the audio signal. The result is in terms of peak values of output voltages of different signals in terms of volts for function generator. Measure the input and output voltage of the sinusoidal waveform for audio power amplifier and note it in terms of volts.
Dear students, today I am going to explain the experiment of the signal generator and the audio power amplifier. Now first I am going to explain the signal generator, how we can generate the signal by using an IC 8038. So the components required to exhibit this experiment is DC regulated dual power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have 2 main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have 2 main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have 2 main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as a channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is a series connection. So this is a series connection in x-axis and this is a series connection in y-axis till this division that will be counted to 5. Till that it is a series connection. After that this is one connection. 1 nanofarad capacitor, 1 nanofarad capacitor used in this experiment. 4 10k resistor, 3 10 kilo ohm resistors and 1 82 kilo ohm resistor I am going to using in this experiment. 8038 IC, this IC will be used to generate the signals from this is the notch. From the notch you can count the terminals, terminal number 1, terminal number 2, 3, 4, 5, 6, 7, and this is 8, 9, 10, 11, 12, 13, 14. This is a 14 pin IC. Connecting wires and patch cards. Now I am going to connect the circuit based upon the circuit diagram of signal generator by using an IC 8038. First I am taking the breadboard, I mount the IC, the breadboard. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So I am taking 10 kilo ohm resistor and I connect the 10 kilo ohm resistor to pin number 4. 1, 2, 3, 4. This is pin number 4 to somewhere in the point I connected here. And again I am taking 10 kilo ohm resistor that will be connected between 5 and the other point somewhere in the circuit that will be already connected with a resistor. Next I am going to short the sixth terminal with the fifth terminal. So this is 3, 4, 5, 6. So this is the sixth terminal. I am going to short with the sixth or the 10 kilo ohm resistor connected. Next I am going to short the pin number 8 and 7. So pin number 7, this is pin number 7, and pin number 8 I am going to short. This is pin number 8. I made it as short. Next pin number 10 I need to connect with a 10 microfarad, pin number 10 that will be connected with a 1 nanofarad. So pin number 10 I am connecting and I placed somewhere here in the point. Next the 12, pin number 12 that will be connected to 82 kilo ohm. Pin number 8, 9, 10, 11, 12 that will be connected to the other point that commonly connected with a capacitor. Next 11 I made it as a short. I am taking another wire. I made the pin number 11, 8, 9, 10, 11 will be shorted with this point. Now I am going to connect the DC dual power supply to pin number 4 or 5. Any point you can connect, or the point that will be left for the connection is this resistors are connected now. This point also we can use, or we can use the pin number 4 or pin number 5, any point we can use. So I am going to connect this positive terminal of the DC power supply to this point. And negative I made it to ground. And the positive of other side that will be connected to ground. The negative will be given to this pin number 12 or pin number 11 or pin number 10, any point, or the common point we are using here is this point I am giving here. Any point you can give. Now I am taking the output port that will be connected to digital oscilloscope. I am taking the wire and I place this wire to find the waveforms in the pin number 9 as a square wave. Pin number 3 is used to generate triangular wave. Pin number 2 that will be used for sine wave generation. So commonly I put this to pin number 9 first, then later on I will change it. 7, 8, 9. This is pin number 9. I will place this one to here. And the negative given to ground, so I will make this to ground. This completes the circuit connection of signal generator. Now you switch on the DC regulated dual power supply and digital oscilloscope. Set the DC regulated dual power supply to 6 volts at both the terminals. That will be set it to 6.2 and this also set it to some 6 volt. Now you can find the square wave at the output. So why? Because we are connected the output terminal to pin number 9. This is pin number 9. It will generate the square wave. So we can find other waves also. So I am connecting this output terminal to pin number 2. Pin number 2, it will give a sine wave. You adjust the So this is a sine wave at pin number 2, and you can get another triangular wave at the pin number 3. I remove this one and I put it into terminal 3. Now I can get the triangular wave. This is the triangular wave. So by using this IC, we can generate square wave, sine wave, and the triangular wave. So this completes the wave generation experiment. Dear students, now I am going to discuss the experiment of audio power amplification by using an IC LM386. The component required for this experiment is signal generator, DC regulated dual power supply, and digital oscilloscope, circuit board, 10K pot. This is a 10K pot I am going to using in this experiment. It contains 3 terminals and 1 knob. This knob I can use for the voltage adjustment. This is LM386 IC. This is the power amplification generation IC. It's an 8-pin IC I am going to use in this experiment. So we have a notch here. From the notch, left side 1, 2, 3, 4, 5, 6, 7, 8, 8-pin ICT. 3 capacitors I am going to using in this experiment. One is 0.1 microfarad, 10 microfarad and 1000 microfarad. So, connecting wires and patch cords. Let us start the circuit connection of audio power amplifier based upon the circuit diagram. Now I am taking the circuit board. I am going to mount the IC, the circuit board. Now I am going to connect the pin number 8 and pin number 1 with 10 microfarad. So this is 10 microfarad. I am taking the 10 microfarad. I am connecting pin number 1 and pin number 8. So this is pin number 1 and this is pin number 8. Now I am going to connect the pin number 7 and pin number 2 with 0.1 microfarad. 0.1 microfarad. I am going to connect the pin number 2. This is pin number 2. Pin number 2 to pin number 7. This pin number 7. Now I am going to connect the pot of 10 kilo ohm. So this point that will be connected to pin number 2. And another port, middle one, that will be connected to pin number 3. This is pin number 3. And the other end that will be connected to ground. I made ground somewhere here. Next, the pin number 5 that will be connected to somewhere in the circuit board to see the output. So I am taking 1000 microfarad that will be connected to pin number 5 to output port. This is connected to pin number 5, 4 and 5. This is pin number 5. This is pin number 5 to somewhere I put it here. Positive connected with this to pin number 5. This is pin number 5. And the negative connected to ground. The negative is connected to ground. Now I am going to connect the pin number 2 to ground. So the pin number 2 is here. And to connect it to ground. Now I am taking the patch cord. I am connecting to the signal generator. I place the positive pin of the signal generator terminal to the pin number 2. This is pin number 2. This is 1 and 2. This is pin number 2. This is pin number 2. I placed the input. The negative terminal that will be made to ground. And the output port to connect. So I'm going to connect the first port to the input signal. The positive of the port that will be connected to, so this point, because I am checking the input now, so I am connecting the input port here. So negative I am going to connect here. So this is the connection of the output port to see the input. Next I am going to connect the output port to see the output signal to channel number 2. The positive I am giving to the pin number 5 that will be connected with the capacitor. Here I need to give the positive terminal. The positive terminal I am giving here, and the negative terminal will made to ground. This completes the circuit connection of audio power amplifier. Now you switch on the signal generator, switch on the digital oscilloscope, switch on the power DC regulated power, switch on the mode in the signal generator, set this to 1 kilohertz frequency. In that 1 kilohertz you set this kilohertz. Increase to some 5-6 volt. This is the output of audio power amplifier. The input, the yellow color sine wave, that is an input, and the blue color wave is an output. So the output will be amplified for the input signal up to 1, 2, 3, 3.5 volt. 3.5 volt it will be amplified. This completes the experiment of audio power amplifier.
At MSR UAS, we spark your imagination unlike any other.